Hello, and welcome to The Sleepy Evolutionist, where evolution meets relaxation and deep time gets cozy. Tonight, we're drifting gently through the vast expanse of neural evolution, exploring the entire story of how brains evolved across 500 million years of thinking. It's a magnificent journey through deep time that connects you to every thought your ancestors ever had, every impulse that kept them alive, and every moment of awareness that led to your own consciousness lying here tonight. Before we begin, I'd love to know where in the world you're listening from and what time it is for you right now. Whether you're settling into bed in Tokyo at midnight, or lying on a couch in London at dawn, or perhaps finding yourself somewhere in between, there's something wonderfully cosmic about how we're all connected through this ancient story of thinking itself. No matter where you are, the same neural patterns that evolved over millions of years are firing in your brain right now, creating thoughts, processing my words, and gently preparing you for sleep. If you find this journey through deep time soothing, I'd be ever so grateful if you gave this video a like and maybe even subscribed. It really helps this quiet corner of evolutionary storytelling grow, reaching other curious minds who might need these gentle expeditions through the vast chronicle of life. Now, I do hope this isn't so fascinating that it keeps you awake with wonder about your own neural heritage. But if it does, well, at least you'll have learned something profound about the incredible evolutionary journey that created your capacity to think, dream, and rest peacefully along the way. So settle in, let your breathing slow to match the patient rhythm of deep time itself, and allow your mind to drift back across the eons. Let's begin this gentle voyage through 500 million years of thinking, where every neuron in your head carries the wisdom of ages, and every thought you have tonight connects you to the vast story of consciousness itself. Across the vast sweep of deep time, approximately 600 million years ago, something remarkable began to stir in Earth's ancient oceans. Picture yourself floating in those primordial waters, warm and rich with the first complex life forms, where the very first sparks of what would become your nervous system began to flicker into existence. These weren't thoughts as you know them, dear listener, but something far more fundamental, the very first electrical whispers that would eventually become the symphony of consciousness you experience tonight. Your most distant ancestors in this neural journey were simple creatures, jellyfish-like beings drifting through ancient seas. They possessed something extraordinary, the first nerve cells, neurons so basic they could barely be called a nervous system, yet they were the humble beginning of every thought you've ever had. These primitive nerve cells were scattered throughout their translucent bodies like tiny stars in a living constellation, each one capable of the most basic function, detecting changes in their environment and triggering simple responses. Imagine, if you will, that first electrical impulse traveling through a nerve cell 600 million years ago. It moved slowly, almost sleepily, carrying information about light or darkness, food or danger, nothing more complex than the biological equivalent of yes or no. Yet within that simple spark lay the potential for everything you are tonight, every complex thought, every emotion, every dream you'll have as you drift off to sleep. Your ancestors' first neurons were learning the most basic language of life, the electrical whispers that said survive, move toward food, move away from harm. These early nervous systems were diffuse networks, spread like gentle webs throughout their bodies. There was no central brain, no command center, just a distributed network of nerve cells communicating through the simplest possible messages. Think of it like a primitive internet, not the complex web we know today, but the most basic network imaginable, where information traveled slowly and purposefully from one node to another. When you feel a gentle sensation spreading through your body as you relax tonight, you're experiencing an echo of that same diffuse neural communication your ancestors knew so well. The beauty of these first neural networks lay in their elegant simplicity. Each nerve cell was both sender and receiver, capable of detecting changes in the environment and passing that information to neighboring cells. Light hitting one part of the creature's body would trigger a cascade of electrical signals, spreading outward like ripples in a pond until the entire organism knew to move toward or away from the stimulus. This distributed processing meant that your ancestors could survive without any centralized thinking, relying instead on the collective wisdom of their scattered nerve cells. As millions of years passed with the patience of deep time itself, these early nervous systems began to develop something profound, the ability to coordinate responses across the entire body. No longer were nerve cells working in isolation. They were beginning to form networks, creating the first neural circuits that could integrate information from multiple sources. Your ancestors were developing the earliest form of what we might call decision-making, though it was still as simple as determining whether to contract muscles on one side of the body or the other. And here you are tonight, your brain containing approximately 86 billion neurons. Each one descended from those first simple nerve cells that learned to share electrical whispers in ancient seas. When you feel that familiar sense of relaxation spreading through your body as you settle into sleep, you're experiencing the same basic neural communication that kept your ancestors alive across the vast epochs of time. Your nervous system still carries within it the memory of those first distributed networks, the gentle electrical conversations between nerve cells that began this entire magnificent story of thinking. The electrical patterns moving through your brain right now, as you listen to these words, are direct descendants of those first tentative neural connections formed in Earth's primordial oceans. There is something beautifully continuous about this journey, how the same basic principles that governed your ancestors' simple nerve nets now orchestrate the complex symphony of consciousness that allows you to understand language, form memories, and drift peacefully toward dreams. Those ancient electrical whispers have become the thoughts that carry you gently toward sleep tonight. Time moves slowly in the grand chronicle of evolution, like a peaceful dream unfolding across millions of years. As we drift forward through deep time to about 500 million years ago, your ancestors began developing something that would change the course of neural evolution forever: the first organized neural networks. These weren't yet brains as we understand them, but they represented a crucial step forward from the scattered nerve cells of their predecessors, the beginning of centralized neural processing that would eventually become your capacity for complex thought. Picture your ancestors now as small, worm-like creatures moving through the ancient seafloor, their bodies equipped with the first true neural networks. These weren't random collections of nerve cells anymore, but organized circuits with specific functions, simple neural pathways that could process information in increasingly sophisticated ways. Think of these early networks like the first telephone systems, basic but functional, allowing different parts of your ancestors' body to communicate more efficiently than ever before. These creatures possessed something remarkable: bilateral symmetry, which meant their nervous systems developed along a central axis with matching neural structures on both sides of their bodies. This symmetry created the first organized neural architecture, networks that could compare information from the left and right sides of the body, process sensory input more effectively, and coordinate responses with unprecedented precision. When you move your left and right hands together tonight, perhaps adjusting your pillow or pulling up a blanket, you're using neural coordination that first evolved in these ancient bilateral ancestors. The development of organized neural networks allowed your ancestors to process information in layers, with some nerve cells specializing in receiving sensory input, while others focused on coordinating motor responses. This division of labor represented a crucial evolutionary insight. That efficiency could be gained by having different neural circuits handle different aspects of survival. Your ancestors were developing the first primitive versions of what we might call sensory processing, the ability to take raw information from the environment and transform it into meaningful signals that could guide behavior. Within these early neural networks, Your ancestors developed something we can recognize as the first neural pathways, consistent routes that electrical signals would travel to accomplish specific tasks. A stimulus detected at the front of the creature would trigger a specific sequence of neural activity, flowing from sensory neurons to processing neurons to motor neurons in a coordinated cascade. This sequential processing represented a fundamental breakthrough in neural organization, the beginning of the step-by-step information processing that characterizes all advanced nervous systems, including your own. As these organized networks became more sophisticated, your ancestors gained the ability to perform what we might call basic learning. Their neural pathways could strengthen with use, making frequently used connections more efficient and reliable. This meant that experiences could literally reshape their nervous systems, allowing them to become better adapted to their specific environments over the course of their lifetimes. When you find certain movements becoming more automatic with practice, or when familiar activities require less conscious attention, you're experiencing this same neural plasticity that first emerged in your ancient networked ancestors. The beauty of these early organized networks lay in their ability to create specialized responses to different types of stimuli. Your ancestors could now distinguish between various kinds of environmental changes with much greater precision, responding appropriately to food signals, danger warnings, and mating opportunities. Their nervous systems had become sophisticated enough to categorize experiences and generate context-appropriate responses, the early foundations of what would eventually become your capacity for complex reasoning and decision-making. Your behavior tonight, as you consciously choose to relax and prepare for sleep, relies on these same principles of organized neural networking that first evolved 500 million years ago. Your brain is using specialized circuits to process auditory information from my voice, emotional centers to create feelings of relaxation, and motor systems to adjust your position for comfort. All of these sophisticated capabilities trace their ancestry back to those first organized neural networks that learned to coordinate information, processing across your ancestors' simple bodies. The organized neural networks of your ancestors also developed the first primitive versions of what we call neural timing, the ability to coordinate the timing of electrical signals across different parts of the nervous system. This temporal coordination allowed for more complex behaviors that required precise sequencing of neural activity. The rhythmic patterns of neural firing that will soon carry you into sleep tonight echo these ancient timing mechanisms, a neural clockwork that first ticked to life in your networked ancestors 500 million years ago. In the quiet vastness of deep time, approximately 480 million years ago, your ancestors achieved something truly remarkable: the development of the first neural ganglia. These were small clusters of nerve cell bodies, primitive neural command centers that represented the earliest hint of what would eventually become your brain. Picture these ganglia as the first neural capitals, small cities of nerve cells that could process information more efficiently than the distributed networks that came before them. Your ancestors at this time were becoming more sophisticated creatures, early arthropods and simple vertebrates beginning to explore the ancient world with increasingly complex behaviors. Their ganglia weren't brains in any sense we would recognize today, but they represented a crucial evolutionary insight that centralizing neural processing in specific locations could dramatically improve an organism's ability to respond to environmental challenges. These clusters of neurons could integrate information from multiple sources, compare different sensory inputs, and generate coordinated responses faster and more accurately than diffuse networks ever could. Think of ganglia as nature's first experiment with specialized neural computing centers. Each ganglion contained hundreds or thousands of nerve cell bodies clustered together, creating a concentrated processing power that could handle specific aspects of survival. Some ganglia specialized in processing visual information, others focused on controlling locomotion, and still others coordinated feeding behaviors. This specialization meant that your ancestors could perform multiple complex tasks simultaneously, a crucial advantage in the competitive world of early Paleozoic seas. The development of ganglia also introduced something profound into the neural landscape, the concept of neural hierarchy. Some ganglia became more important than others, acting as higher-level control centers that could influence the activity of subordinate neural clusters. This hierarchical organization represented the first primitive version of what would eventually become the complex command and control structure of your modern brain. When you make a conscious decision tonight to shift position for comfort, you're using hierarchical neural control that first emerged in these ancient ganglionic ancestors. Within each ganglion, nerve cells began to develop increasingly specialized functions. Some neurons became dedicated sensory processors, others focused on motor control, and still others served as interneurons that could integrate information from multiple sources. This cellular specialization within ganglia created the first true neural circuits, organized pathways through which information could flow in predictable and efficient patterns. Your ancestors were developing the earliest versions of what neuroscientists now call neural modules, specialized processing units that could handle specific computational tasks. The ganglia of your ancestors also developed the first primitive forms of neural memory, the ability to store and recall patterns of neural activity that had proven useful in the past. Simple experiences could leave lasting changes in the connections between neurons within a ganglion, creating neural traces that could influence future behavior. This memory storage meant that your ancestors could learn from experience in ways their predecessors never could, accumulating neural wisdom that made them increasingly effective at surviving in their environments. As ganglia became more sophisticated, they began to communicate with each other through bundles of nerve fibers, creating the first neural networks that spanned entire bodies. These interganglionic connections allowed different processing centers to share information and coordinate their activities. Your ancestors were developing primitive versions of what we now call neural integration, the ability to combine information from multiple sources to create unified perceptions and coordinated responses. The electrical activity within your ancestors' ganglia followed rhythmic patterns that we can still observe in modern nervous systems. These neural rhythms helped coordinate the timing of different processes, ensuring that sensory input, processing, and motor output could work together seamlessly. As you prepare for sleep tonight, your brain will shift into different patterns of rhythmic activity, delta waves and sleep spindles that echo the ancient neural rhythms first established in your ganglionic ancestors. Your ancestors' ganglia also developed the first crude forms of what we might call attention, the ability to prioritize certain types of information over others. When multiple sensory signals arrived simultaneously, ganglia could enhance processing of the most important inputs while suppressing less critical information. This selective attention meant that your ancestors could focus their limited neural resources on the most survival-relevant aspects of their environment, a crucial capability that you still use every night as your brain filters out irrelevant stimuli to allow peaceful sleep. The ganglia that evolved in your ancestors 480 million years ago represented more than just neural processing centers. They were the first experiments in concentrated consciousness, primitive focal points where the scattered electrical activity of nervous systems began to coalesce into something approaching unified experience. While these early ganglia couldn't generate anything like human consciousness, they established the fundamental principle that would eventually lead to your capacity for self-aware thought. The idea that centralizing neural activity could create experiences greater than the sum of their parts. Across the vast epochs of time, around 450 million years ago, your ancestors made another crucial leap in neural evolution, developing the first structures that could truly be called brains. These weren't the complex brains of modern animals, but they represented a fundamental shift from the scattered ganglia of their predecessors to centralized neural command centers that could coordinate increasingly sophisticated behaviors. Picture these early brains as the first neural governments, small but organized centers of processing power that could make decisions affecting entire organisms. Your ancestors at this time included early vertebrates, primitive fish swimming through ancient seas, and various invertebrates exploring the ocean floors with increasing neural sophistication. Their brains were small, often no larger than poppy seeds, but they contained within them the seeds of every complex thought you'll ever have. These early brains established the basic principles of centralized neural processing, creating dedicated regions for different functions and allowing for increasingly complex integration of sensory information. The most remarkable feature of these early brains was their ability to create unified experiences from multiple sensory inputs. Where ganglia had processed information in relative isolation, brains could combine visual, chemical, and mechanical stimuli into coherent perceptions of the environment. Your ancestors were developing the first primitive versions of what we call perceptual binding, the neural process that allows you tonight to perceive my words, the comfort of your bed, and the gentle approach of sleep as parts of a unified conscious experience. These simple brains also introduced something profound into the story of neural evolution, the capacity for increasingly complex learning and memory. Unlike the basic associative learning of ganglionic ancestors, brain-equipped creatures could form sophisticated memories that linked multiple pieces of information together. They could remember not just that certain stimuli were dangerous or beneficial, but the complex circumstances under which these associations applied. This contextual memory meant that your ancestors could navigate their world with unprecedented sophistication. Within these early brains, different regions began to specialize in different aspects of neural processing. Some areas focused on sensory integration, others coordinated motor responses, and still others began to develop the first primitive versions of what we might call executive control, the ability to evaluate different possible responses and choose the most appropriate action. This regional specialization created the first neural architecture that could support complex decision-making, the humble beginning of the sophisticated cognitive abilities you use every moment of your conscious life. The development of brains also brought with it the first sophisticated forms of neural plasticity, the ability of nervous systems to reorganize themselves in response to experience. Your ancestors' brains could literally rewire themselves, strengthening useful connections and weakening those that proved less valuable for survival. This neural flexibility meant that each individual could develop unique neural patterns suited to their specific experiences and environments, the beginning of what we might recognize as individual neural identity. Communication between different brain regions became increasingly sophisticated, with bundles of nerve fibers creating high-speed information highways that connected specialized processing areas. These neural pathways allowed different parts of the brain to work together seamlessly, creating the first integrated neural systems capable of supporting complex behaviors. When you coordinate the multiple neural processes required for understanding language, forming memories, and relaxing into sleep tonight, you're using integration capabilities that first evolved in these simple ancestral brains. Your ancestors' brains also developed the first sophisticated forms of neural timing and rhythm. Different brain regions began to synchronize their electrical activities, creating coordinated patterns of neural firing that could support complex behaviors. These neural rhythms helped coordinate everything from basic movements to more sophisticated processes like memory formation. As your brain shifts into sleep rhythms tonight, it will use timing mechanisms that first evolved in your simple-brained ancestors 450 million years ago. The brains of your ancestors also began to show the first signs of what we might call emotional processing, simple neural circuits that could evaluate stimuli, not just for their survival relevance, but for their broader significance to the organism's well-being. These primitive emotional systems created the capacity for more nuanced responses to environmental challenges, the beginning of the complex emotional life that helps you feel safe and relaxed as you prepare for sleep tonight. Perhaps most remarkably, these early brains began to exhibit the first hints of what we might call predictive processing, the ability to anticipate future events based on past experience. Your ancestors could begin to model what might happen next in their environment, allowing them to prepare for challenges before they fully materialized. This predictive capability represented a crucial step toward the complex planning and anticipation abilities that allow you to prepare for tomorrow's activities while drifting peacefully toward tonight's dreams. In the grand tapestry of evolution, roughly 400 million years ago, your ancestors underwent one of the most crucial developments in the history of neural evolution, the emergence of the spinal cord. This wasn't just another neural structure, but a revolutionary innovation that would define the basic architecture of your own nervous system tonight. The spinal cord represented the first true neural superhighway, a high-speed information conduit that could connect brain and body with unprecedented efficiency and sophistication. Picture your ancestors at this time as early vertebrates, primitive fish and proto-amphibians beginning to explore both aquatic and terrestrial environments with increasingly complex behaviors. Their newly evolved spinal cords ran like neural cables down the length of their bodies, protected within bony or cartilaginous vertebral columns that gave vertebrates their name. This central neural highway created possibilities for neural organization and behavioral complexity that had never existed before in the history of life on Earth. The spinal cord transformed how information could flow through your ancestors' bodies. Instead of the relatively slow and diffuse neural communication of earlier creatures, the spinal cord provided a direct, high-speed connection between brain and body. Sensory information from throughout the body could rapidly reach the brain for processing, while motor commands from the brain could quickly reach muscles throughout the body. This speed and efficiency of neural communication meant that your ancestors could respond to environmental challenges faster and more precisely than any creatures that had come before them. Within the spinal cord itself, your ancestors developed sophisticated neural circuits that could process certain types of information automatically, without requiring input from the brain. These spinal circuits could coordinate basic movements, process simple sensory information, and even generate rhythmic patterns of activity that supported locomotion. Your ancestors were developing the first versions of what neuroscientists now call spinal central pattern generators, neural circuits that could produce complex, coordinated movements largely independently of higher brain control. The development of the spinal cord also introduced a new level of neural organization, the concept of hierarchical control with the brain as the ultimate command center, and the spinal cord is both information highway and local processing center. This hierarchy meant that your ancestors could engage in both automatic, reflexive behaviors controlled by spinal circuits and more complex, deliberative actions coordinated by the brain. When you automatically adjust your position while sleeping tonight without conscious awareness, you're using spinal control circuits that first evolved in these ancestral vertebrates. The spinal cord's neural architecture also established the basic principles of sensory and motor organization that still characterize your nervous system today. Sensory information traveled up the spinal cord in specific pathways, with different types of sensory input taking different routes to reach appropriate brain regions. Motor commands traveled down the spinal cord in other specific pathways, with precise organization ensuring that brain signals could reach the intended muscles quickly and accurately. Your ancestors' spinal cords developed increasingly sophisticated systems for processing different types of sensory information. Touch, temperature, pain, and proprioceptive information each followed distinct pathways through the spinal cord, with specialized neural circuits processing each type of sensation appropriately before sending it on to brain regions. This parallel processing meant that your ancestors could simultaneously monitor multiple aspects of their internal and external environments, a capability you still rely on as your body continuously monitors comfort, temperature, and position while you rest tonight. The motor control capabilities enabled by spinal cord evolution were equally revolutionary. Your ancestors could now coordinate complex movements involving multiple muscle groups across their entire bodies. Swimming, walking, feeding, and escaping from predators all became more sophisticated as spinal motor circuits learned to orchestrate precisely timed patterns of muscle contraction and relaxation. The graceful coordination of movement that allows you to shift positions smoothly while falling asleep tonight depends on spinal motor control systems that first evolved in your vertebrate ancestors 400 million years ago. The spinal cord also introduced new possibilities for neural learning and memory. Spinal circuits could be modified by experience, allowing your ancestors to refine their movements and responses through practice. This spinal plasticity meant that frequently performed actions could become more automatic and efficient over time, freeing brain resources for more complex cognitive tasks. Your effortless ability to breathe regularly while sleeping relies on spinal circuits that learn to coordinate respiratory movements without conscious intervention. Protection of the spinal cord within the vertebral column represented another crucial innovation, ensuring that this vital neural superhighway could function reliably throughout your ancestors' lifetimes. The bony or cartilaginous protection around the spinal cord reflected its crucial importance to survival. Nature's recognition that this neural structure was too valuable to risk damage from environmental hazards. As your ancestors' spinal cords became more sophisticated, they developed increasingly complex connections with the brain, creating feedback loops that allowed brain and spinal cord to work together as an integrated neural system. Sensory information processed by spinal circuits could modify brain activity, while brain activity could adjust the sensitivity and responsiveness of spinal circuits. This dynamic interaction between brain and spinal cord created the foundation for the sophisticated neural integration that allows your brain and body to work together seamlessly as you drift towards sleep tonight. The neural rhythms generated by spinal circuits also began to influence brain activity, creating the first versions of the complex neural oscillations that characterize modern nervous systems. These rhythms helped coordinate different aspects of neural processing, ensuring that sensory input, motor output, and higher-level cognitive processing could all work together harmoniously. The gentle neural rhythms that will carry you into sleep tonight echo these ancient spinal patterns that first synchronized brain and body activity in your vertebrate ancestors. Time flows like a gentle river through the vast chronicle of evolution, carrying us forward to approximately 350 million years ago, when your ancestors achieved something truly extraordinary, the development of specialized brain regions that would form the foundation of all future neural complexity. These early vertebrates, primitive fish and early amphibians beginning to explore terrestrial environments, evolved brains with distinct anatomical divisions, each specialized for different aspects of neural processing. This regional brain organization established the basic architectural principles that still govern your own brain tonight as it processes these words and prepares for peaceful sleep. Your ancestors' brains began to organize themselves into three primary divisions: the hindbrain, midbrain, and forebrain, each with specialized functions that complemented the others. The hindbrain controlled basic life functions like breathing, circulation, and balance, establishing the rhythmic processes that keep organisms alive without conscious effort. Even now, as you rest comfortably tonight, your hindbrain descendants work tirelessly to maintain steady breathing and circulation, their ancient neural circuits carrying out the same essential functions that kept your ancestors alive throughout hundreds of millions of years of evolutionary time. The midbrain of your ancestors became the primary center for processing sensory information and coordinating reflexive responses. This brain region specialized in rapid, automatic reactions to environmental stimuli, particularly those related to survival threats or opportunities. Your ancestors could now respond to visual movement, auditory signals, and other sensory cues with lightning-fast precision, their midbrain circuits triggering appropriate responses before conscious processing was even necessary. When you automatically startle at an unexpected sound tonight, before your conscious mind even registers what happened, you're experiencing the instantaneous midbrain reflexes that first evolved in these ancient ancestors. The forebrain represented the most revolutionary development, becoming the seat of increasingly sophisticated cognitive abilities. In these early stages, the forebrain was primarily dedicated to processing chemical information, the complex world of smells and tastes that guided your ancestors through their ancient environments. But within this chemically focused forebrain lay the seeds of all future cognitive complexity, the neural structures that would eventually become capable of language, abstract thought, and the conscious awareness that allows you to understand these words tonight. Regional specialization meant that different brain areas could become increasingly efficient at their specific functions, while simultaneously contributing to the overall coordination of behavior. Your ancestors developed neural systems where sensory processing, motor control, and basic cognitive functions could operate both independently and as integrated components of unified behavioral responses. This modular organization created unprecedented flexibility, allowing creatures to engage in complex behaviors that required multiple brain regions working together seamlessly. The connections between different brain regions became increasingly sophisticated, with bundles of nerve fibers creating information highways that allowed rapid communication between specialized processing centers. Your ancestors' brains developed the first versions of what neuroscientists now call neural networks, interconnected systems of brain regions that could share information and coordinate their activities to support complex behaviors. These ancient neural networks established the foundation for the integrated brain activity that allows you to simultaneously process language, access memories, regulate emotions, and prepare for sleep tonight. Memory systems also became more sophisticated with regional brain specialization. Different brain areas could store different types of information, with some regions specializing in sensory memories, others in motor memories, and still others in more complex associations between different types of experiences. Your ancestors could now form rich, multifaceted memories that linked together information from multiple sensory modalities and behavioral contexts, the beginning of the complex memory systems that allow you to recall experiences, learn skills, and emotional associations with remarkable precision. The development of specialized brain regions also enabled the first, sophisticated forms of what we might call emotional processing. Certain brain areas became dedicated to evaluating the emotional significance of experiences, generating appropriate physiological and behavioral responses to different types of situations. Your ancestors could now experience something approaching what we recognize as emotions, neural states that influenced both immediate behavior and longer-term learning about which experiences were beneficial or harmful. Neural plasticity reached new levels of sophistication in these regionally specialized brains. Different brain areas could modify their structure and function in response to experience, but now these modifications could be more targeted and specific. Frequently used neural pathways could be strengthened within particular brain regions, while other areas remained relatively unchanged, allowing for precise fine-tuning of neural function based on individual experience and environmental demands. The rhythmic neural activity that characterized these specialized brain regions created the first complex patterns of neural oscillations that synchronized activity across different areas of the brain. These neural rhythms helped coordinate information processing between brain regions, ensuring that sensory input, memory retrieval, emotional evaluation, and motor planning could all work together efficiently. As your brain shifts into synchronized sleep rhythms tonight, It will use coordination mechanisms that first evolved in your regionally specialized ancestors 350 million years ago. Communication between brain and body also became more sophisticated with regional specialization. Different brain areas could send specific types of signals to different parts of the body, enabling precise control over various physiological and behavioral responses. Your ancestors could now coordinate complex behaviors that required fine-tuned interaction between neural control systems and bodily functions, the beginning of the sophisticated mind-body integration that allows you to regulate your breathing, heart rate, and muscle tension as you settle into peaceful sleep tonight. The specialized brain regions of your ancestors also began to show the first signs of what we might recognize as personality differences between individuals. Variations in the development and function of different brain areas could lead to consistent differences in behavior, learning ability, and responses to environmental challenges. Your ancestors were becoming individuals in ways that earlier creatures with less specialized brains never could, each carrying unique patterns of regional brain development that influenced their particular approaches to survival and reproduction. In the magnificent chronicle of deep time, approximately 300 million years ago, your ancestors underwent one of the most fundamental transformations in the history of neural evolution, the development of what neuroscientists call the reptilian brain. These were the first neural systems dedicated entirely to survival, primitive but incredibly effective brain structures that could coordinate the complex behaviors necessary for life in increasingly challenging terrestrial environments. Picture your ancestors as early reptiles, the first vertebrates to achieve true independence from aquatic environments, their brains evolving powerful new capabilities for navigating the dangers and opportunities of life on land. The reptilian brain represented nature's first masterpiece of pure survival engineering, neural circuits honed by millions of years of evolution to perform the essential functions of staying alive with ruthless efficiency. These brain structures specialized in the four fundamental behaviors that determine life or death: fighting, fleeing, feeding, and reproducing. Your ancestors developed neural systems that could evaluate situations instantly and trigger appropriate survival responses without hesitation or second guessing. When you experience that instant alertness in response to potential danger tonight, or the immediate relaxation when you recognize safety and comfort, you're feeling the influence of reptilian brain circuits that have been protecting your lineage for 300 million years. The basal ganglia, deep brain structures that became the core of reptilian neural architecture, evolved to coordinate complex motor behaviors with unprecedented precision. Your ancestors could now engage in sophisticated hunting behaviors, territorial disputes, and mating rituals that required precise timing and coordination of multiple muscle groups throughout their bodies. These ancient motor control centers learned to chain together sequences of movements into fluid, purposeful behaviors, the foundation of all complex motor skills, including the subtle adjustments your body makes automatically as you settle into comfortable positions for sleep tonight. Territory and hierarchy became central organizing principles of reptilian brain function, reflecting the harsh realities of survival in competitive terrestrial environments. Your ancestors evolved neural circuits that could establish and maintain social dominance, defend territories, and navigate complex social hierarchies with other members of their species. These social control systems created the first sophisticated behavioral strategies for balancing competition and cooperation, establishing neural templates for social behavior that still influence human interactions today. The social comfort you might feel lying safely in your own space tonight activates descendant circuits of these ancient, territorial brain systems. The reptilian brain also pioneered the development of sophisticated ritual behaviors, complex sequences of actions that served crucial survival and reproductive functions. Your ancestors could perform elaborate courtship displays, territorial marking behaviors, and threat displays that communicated vital information to other members of their species. These ritual behaviors required neural systems capable of storing and executing complex behavioral programs, the beginning of the sophisticated motor memory systems that allow you to perform learned skills automatically without conscious effort. Aggression and self-defense reached new levels of neural sophistication in the reptilian brain, with specialized circuits that could coordinate everything from simple threat responses to complex predatory strategies. Your ancestors developed neural systems that could assess threats rapidly, calculate risks and benefits of different response options, and execute appropriate defensive or offensive behaviors with deadly precision. These ancient aggression circuits underwent careful evolutionary modification in later ancestors, eventually becoming the assertiveness and protective instincts that help you maintain personal boundaries and ensure your safety in modern environments. The reptilian brain's approach to learning was fundamentally different from the more sophisticated learning systems that would evolve later. These ancient neural circuits specialized in rapid, permanent learning about survival-critical information. Once your ancestors learned that something was dangerous or beneficial, that information became deeply embedded in their neural architecture, creating lasting behavioral modifications that could persist throughout their lifetimes. This type of deep, instinctual learning still influences your behavior tonight, creating the immediate sense of safety and comfort you feel in familiar environments. Hormonal integration reached new levels of sophistication as the reptilian brain evolved close connections with endocrine systems. Your ancestors could now coordinate neural responses with hormonal changes, creating unified physiological responses to different environmental challenges. Stress hormones, reproductive hormones, and other chemical messengers became integrated components of behavioral control systems, allowing for complex responses that involved both immediate neural activity and longer-term physiological modifications. As your body naturally shifts into sleep-promoting hormonal states tonight, it's using integration mechanisms that first evolved in your reptilian ancestors. The neural circuits of the reptilian brain also developed increasingly sophisticated systems for evaluating and responding to environmental rhythms. Your ancestors became exquisitely sensitive to daily cycles of light and darkness, seasonal changes, and other environmental patterns that influenced survival and reproduction. These circadian control systems learned to coordinate behavioral and physiological responses with predictable environmental changes, maximizing survival success through precise temporal coordination. The circadian rhythms that will guide your sleep-wake cycle tonight are direct descendants of these ancient reptilian timing systems. Memory consolidation became more sophisticated in the reptilian brain, with specialized systems for converting temporary experiences into permanent neural modifications. Your ancestors could now form lasting memories about territorial boundaries, social hierarchies, successful hunting strategies, and potential dangers. These memory systems operated largely below conscious awareness, creating instinctual knowledge that could guide behavior without requiring deliberate recall or analysis. The intuitive sense of safety and comfort you feel in your sleeping environment tonight relies on these same unconscious memory processes. The reptilian brain represented a crucial bridge between the basic survival systems of earlier ancestors and the more sophisticated cognitive abilities that would evolve later. While focused primarily on immediate survival needs, these neural systems established important principles of brain organization that would influence all subsequent neural evolution. The efficiency, reliability, and persistence of reptilian brain circuits provided a stable foundation upon which more complex neural capabilities could be built, ensuring that basic survival functions would continue to operate effectively even as brains became capable of increasingly sophisticated behaviors. The deep, instinctual wisdom embedded in reptilian brain circuits continues to operate within your own nervous system tonight, maintaining essential life functions, monitoring your environment for potential threats, and creating the deep sense of biological security that allows you to relax completely and drift peacefully toward sleep. These ancient neural systems represent your brain's most fundamental commitment to keeping you safe and alive, a 300-million-year-old promise that continues to watch over you as you rest. Across the vast sweep of time, approximately 250 million years ago, your ancestors achieved another remarkable breakthrough in neural evolution, the development of the limbic system and the birth of emotional experience as we recognize it today. These early mammal-like reptiles, the therapsids, and their descendants, were evolving brain structures capable of generating rich internal experiences that went far beyond the immediate survival focus of their reptilian ancestors. Picture these creatures developing the first capacity for something approaching love, fear, joy, and attachment, emotions that would transform the entire landscape of what it meant to be alive and conscious. The limbic system represented nature's first experiment with internal emotional states that could influence behavior over extended periods of time. Where the reptilian brain focused on immediate responses to environmental challenges, the limbic brain could create lasting emotional memories that colored future experiences with feelings of safety or danger, approach or avoidance, comfort or distress. Your ancestors were developing the capacity to form emotional relationships with their environments and with each other, creating the first bonds of attachment that would eventually become the complex emotional connections humans experience today. At the heart of this emotional revolution was the development of sophisticated memory systems that could link experiences with emotional significance. The hippocampus, a curved structure deep within the limbic brain, became specialized for forming detailed memories of places, events, and contexts, while the amygdala developed into the brain's alarm system, rapidly evaluating the emotional significance of experiences and triggering appropriate physiological and behavioral responses. Your ancestors could now remember not just what happened, but how they felt when it happened, creating rich emotional contexts that influenced all future learning and behavior. The limbic system also introduced something profound into neural evolution, the capacity for what we might call caregiving behaviors. Your mammalian ancestors evolved brain circuits that could generate feelings of attachment to other individuals, particularly to offspring who required extended periods of care and nurturing. These ancient emotional systems created the first capacity for parental love, the deep biological commitment to protecting and nurturing young. That would become one of the most powerful forces in mammalian evolution. The comfort and security you feel in caring relationships tonight activates these same ancient emotional circuits that first evolved to strengthen family bonds. Social behavior reached unprecedented levels of complexity as limbic emotional systems enabled your ancestors to navigate increasingly sophisticated group dynamics. They could now form lasting social bonds, recognize individual members of their social groups, and coordinate group activities through emotional communication. Play behavior emerged as young mammals learned to practice adult skills in emotionally safe contexts, developing both physical abilities and social relationships through joyful interactions that strengthened community bonds. The contentment you might feel thinking about pleasant social connections tonight reflects these ancient systems for emotional social bonding. The limbic brain also pioneered the development of sophisticated stress response systems that could coordinate emotional, physiological, and behavioral responses to challenging situations. Your ancestors evolved the capacity to experience anxiety in response to potential future threats, allowing them to prepare for challenges before they actually materialized. This anticipatory anxiety, while sometimes uncomfortable, provided crucial survival advantages by motivating protective behaviors and careful planning. The relief you feel as stress melts away during relaxation tonight involves limbic circuits that learn to signal safety and promote recovery from stress. Communication became enriched with emotional content as limbic systems enabled your ancestors to express and recognize emotional states through vocalizations, body postures, and facial expressions. Mother-infant communication became particularly sophisticated, with caregivers and offspring developing rich repertoires of emotional signals that strengthened their bonds and facilitated learning. These early emotional communication systems established the foundation for all future social communication, including the emotional undertones that make human language so rich and meaningful. The limbic system introduced new levels of neural plasticity that allowed emotional learning throughout life. Unlike the relatively fixed instincts of reptilian ancestors, limbic emotional systems could be modified by experience, allowing individuals to adapt their emotional responses based on their unique life experiences. Your ancestors could learn to associate new situations with emotional significance, forming personalized emotional maps of their environments that guided future behavior. This emotional learning flexibility meant that each individual could develop unique emotional personalities suited to their particular circumstances. Motivation and reward processing reached new sophistication as limbic systems evolved, specialized circuits for evaluating the desirability of different experiences. The nucleus accumbens and related structures became the brain's reward center, generating feelings of pleasure and satisfaction in response to beneficial experiences like finding food, successful mating, or social bonding. These reward systems created powerful motivational forces that could guide learning and behavior toward life-enhancing activities. The pleasant anticipation of sleep and rest that you might feel tonight activates these same ancient reward circuits. The limbic brain also developed increasingly sophisticated systems for regulating arousal and attention. Your ancestors could now modulate their alertness levels based on emotional context, becoming highly vigilant in potentially dangerous situations while relaxing deeply in safe, comfortable environments. These arousal regulation systems allowed for more efficient energy management, ensuring that high alert states were reserved for times when they were truly needed, while promoting recovery and restoration during safe periods. Sleep itself became more sophisticated with limbic evolution, as emotional processing began to influence sleep patterns and dream content. Your ancestors developed the capacity for REM sleep, during which emotional memories could be consolidated and integrated with existing knowledge. Dreams began to serve important functions in emotional processing, allowing the brain to work through challenging experiences and strengthen beneficial emotional learning. The peaceful sleep you'll soon experience tonight represents the culmination of these ancient limbic innovations in sleep-related emotional processing. The emotional wisdom embedded in your limbic system continues to enrich every moment of your conscious experience, creating the emotional coloring that makes life meaningful rather than merely functional. As you prepare for sleep tonight, limbic circuits are generating feelings of safety, comfort, and anticipation of rest, coordinating with other brain systems to create the complex emotional state we recognize as peaceful relaxation. These emotional systems represent your brain's commitment not just to keeping you alive, but to making your life rich with meaning, connection, and the full spectrum of emotional experience. In the grand chronicle of neural evolution, approximately 200 million years ago, your ancestors underwent another revolutionary transformation with the development of the neocortex, the first brain structure capable of what we might recognize as complex thinking, planning, and learning. These early mammals, small creatures navigating the dangerous world dominated by dinosaurs, evolved a new layer of brain tissue that would eventually become the seat of consciousness, creativity, and abstract thought. Picture your ancestors developing the first glimmers of the intellectual capabilities that allow you tonight to understand language, form complex memories, and engage in the sophisticated cognitive processes that make human consciousness possible. The neocortex represented nature's first experiment with layered information processing, a neural architecture that could analyze incoming information through multiple levels of increasingly sophisticated analysis. Unlike the more direct processing of earlier brain structures, The neocortex developed a six-layered organization where information would percolate through successive levels of neural circuits, each layer adding new dimensions of analysis and interpretation. Your ancestors were developing the foundation for the complex thought processes that allow you to understand not just what is happening around you, but what it means in broader contexts of knowledge and experience. This new cortical architecture introduced unprecedented flexibility in learning and behavioral adaptation. Where earlier brain structures relied heavily on genetically programmed responses and relatively fixed learning patterns, the neocortex could form new associations, develop novel solutions to environmental challenges, and adapt behavioral strategies based on changing circumstances. Your ancestors became capable of innovation, developing new approaches to survival challenges rather than relying exclusively on inherited behavioral programs. The creativity and problem-solving abilities you might use in your daily life draw upon these ancient cortical systems for flexible thinking. Sensory processing reached remarkable new levels of sophistication as the neocortex evolved specialized regions for analyzing different types of sensory information. Visual cortex could now extract complex features from visual scenes, recognizing objects, movements, and spatial relationships with unprecedented precision. Auditory cortex could analyze the temporal patterns and frequency compositions of sounds, enabling your ancestors to navigate their world through sophisticated acoustic analysis. The rich sensory experience you have tonight, perceiving the subtle qualities of sounds, textures, and visual stimuli, relies on cortical processing systems that first evolved in your early mammalian ancestors. Motor control was revolutionized by cortical evolution. As the neocortex developed the capacity for precise, voluntary movement control that could override reflexive responses when circumstances required it. Your ancestors could now engage in skilled movements that required conscious planning and execution, manipulating objects and navigating complex environments with remarkable dexterity. The motor cortex established the foundation for all skilled behaviors, from the precise hand movements required for tool use to the complex vocal controls necessary for sophisticated communication. The neocortex also pioneered the development of neural systems capable of temporal integration, the ability to link events separated in time into coherent sequences of cause and effect. Your ancestors could now understand that actions in the present might have consequences in the future, enabling sophisticated planning and anticipatory behaviors. This temporal thinking allowed for much more complex survival strategies, as ancestors could prepare for seasonal changes, plan complex foraging expeditions, and engage in behaviors whose benefits might not be immediate, but would prove valuable over longer time scales. Memory systems became dramatically more sophisticated with cortical evolution, developing the capacity to store and integrate vast amounts of detailed information about experiences, environments, and learned skills. The cortical memory networks could form rich associative links between different pieces of information, creating complex knowledge structures that could support flexible thinking and creative problem-solving. Your ancestors could now accumulate detailed knowledge about their environments and use this information to make informed decisions in novel situations. Social cognition took a major leap forward as cortical systems enabled your ancestors to develop increasingly sophisticated models of other individuals' behaviors, motivations, and likely future actions. The neocortex could now support complex social strategies that required understanding not just what others were doing, but why they were doing it and what they might do next. This social intelligence created possibilities for cooperation and communication that had never existed before, laying the groundwork for the complex social systems that would characterize advanced mammals. Pattern recognition became one of the neocortex's greatest strengths, with neural circuits that could identify complex patterns in sensory information, behavioral sequences, and environmental regularities. Your ancestors could now recognize subtle environmental cues that predicted important changes. Identify individual members of their species based on complex combinations of features, and learn complex behavioral sequences through pattern-based learning. The pattern recognition abilities that help you navigate complex modern environments draw upon these ancient cortical capabilities. The neocortex also introduced new levels of neural integration, developing long-range connections that could coordinate information processing across widely distributed brain regions. Different cortical areas could share information and coordinate their activities to support complex behaviors that required integration of sensory, motor, cognitive, and emotional processing. This neural integration created the foundation for unified conscious experience, the seamless coordination of multiple brain functions that allows you to perceive, think, feel, and act as an integrated whole. Language capabilities began to emerge from cortical evolution. As neural circuits developed, they could associate arbitrary sounds or gestures with specific meanings and combine these elements according to systematic rules. While early mammalian communication was far simpler than human language, the cortical mechanisms for symbolic communication and grammatical organization were beginning to evolve. The language comprehension that allows you to understand these words tonight represents the culmination of cortical language systems that began evolving 200 million years ago. The neocortex of your ancestors also developed increasingly sophisticated systems for controlling attention and consciousness, determining which information would receive focused processing and which would remain in the background of awareness. These attention control systems allowed for much more efficient use of limited neural resources, ensuring that the most important information received the most detailed analysis, while less critical information was processed more automatically. As your own neocortex continues the ancient work of information processing tonight, integrating sensory input, accessing memories, planning future activities, and gradually shifting toward the altered states of consciousness that characterize sleep, you're experiencing the culmination of this remarkable evolutionary journey from simple neural circuits to the sophisticated cognitive architecture that makes complex thought possible. The neocortex represents your brain's greatest evolutionary achievement, the integral foundation for all the complex mental abilities that make human consciousness both possible and magnificent. Time drifts slowly through the vast epochs of neural evolution, carrying us forward to approximately 150 million years ago, when your ancestors achieved something truly remarkable, the development of specialized brain hemispheres that began to divide cognitive labor between the left and right sides of the brain. These early mammals, ancestors of modern placental mammals, evolved a neural innovation that would eventually enable the complex, multi-layered thinking that characterizes advanced mammalian consciousness. Picture your ancestors developing the first versions of the hemispheric specialization that allows your brain tonight to simultaneously process language, spatial information, emotions, and sensory input through parallel processing systems working in sophisticated harmony. Hemispheric specialization represented nature's solution to the challenge of increasing cognitive complexity without overwhelming neural processing capacity. Rather than simply adding more neurons to handle increasing cognitive demands, evolution developed a strategy of dividing different types of cognitive tasks between specialized brain hemispheres that could work both independently and cooperatively. Your ancestors were pioneering the first versions of what neuroscientists now call lateralized brain function, the division of cognitive labor that makes complex, parallel information processing possible. The left hemisphere of your ancestors' brains began to specialize in sequential, analytical processing, becoming particularly adept at handling information that needed to be processed in temporal order or broken down into component parts. This hemisphere developed enhanced capabilities for motor control, particularly for complex, skilled movements that required precise timing and coordination. Your ancestors could now engage in increasingly sophisticated manipulative behaviors, using their limbs and appendages to interact with their environment in complex, goal-directed ways. A precise motor control that allows you to make subtle adjustments to your position for comfort tonight relies on left hemisphere motor systems that first evolved in these lateralized ancestors. The right hemisphere simultaneously developed complementary specializations, becoming expert in holistic spatial processing that could integrate information into unified wholes. This hemisphere became particularly skilled at processing spatial relationships, recognizing complex patterns, and integrating multiple simultaneous inputs into coherent perceptions. Your ancestors could now navigate complex three-dimensional environments with remarkable precision, recognizing landmarks, remembering spatial layouts, and planning efficient routes through complex terrains. The spatial awareness that helps you orient yourself in your sleeping space tonight draws upon right hemisphere systems that evolved for sophisticated environmental navigation. Communication between the brain hemispheres became increasingly sophisticated through the evolution of the corpus callosum, a massive bundle of nerve fibers that allowed rapid information exchange between left and right brain systems. This interhemispheric communication meant that the specialized processing capabilities of each hemisphere could be combined and integrated, creating cognitive abilities that were greater than the sum of their parts. Your ancestors could now engage in complex behaviors that required both analytical and holistic processing, switching flexibly between different cognitive modes as circumstances required. The emotional processing systems of your ancestors also began to show hemispheric specialization, with different aspects of emotional experience becoming lateralized to different brain sides. The right hemisphere developed enhanced capabilities for processing emotional context and social information, while the left hemisphere specialized in the more analytical aspects of emotional evaluation and response planning. This emotional lateralization allowed for more sophisticated emotional intelligence, as your ancestors could simultaneously experience emotions and analyze their significance for survival and social success. Visual processing underwent remarkable development with hemispheric specialization, as different visual functions became distributed between brain hemispheres. Your ancestors developed enhanced capabilities for recognizing faces, processing visual motion, and integrating visual information with other sensory inputs. The visual system began to show the first hints of what would eventually become the complex visual processing capabilities that allow humans to create and appreciate art, recognize complex visual patterns, and navigate visually rich environments. The visual processing that allows you to perceive your peaceful environment tonight relies on these ancient hemispheric visual systems. Memory systems also became more sophisticated with hemispheric specialization, as different types of memory began to show preferential processing in different brain hemispheres. The left hemisphere became particularly skilled at verbal and sequential memory, while the right hemisphere specialized in spatial and configural memory systems. Your ancestors could now form and recall increasingly complex memories that integrated multiple types of information, creating rich experiential memories that could guide future behavior with unprecedented sophistication. Attention control reached new levels of refinement with hemispheric specialization, as different attention systems became distributed between brain hemispheres. Your ancestors developed the capability to simultaneously maintain focused attention on specific stimuli while monitoring the broader environment for unexpected changes or opportunities. This divided attention allowed for much more efficient environmental monitoring and response preparation, crucial capabilities for creatures navigating complex and potentially dangerous environments. The lateralized brain also enabled new forms of behavioral flexibility, as your ancestors could switch between different processing modes depending on task demands. Complex problems could be approached through either analytical, step-by-step processing or holistic, pattern-based analysis, with the corpus callosum enabling rapid switching between these different cognitive approaches. This cognitive flexibility provided significant advantages in variable environments where different types of challenges required different types of solutions. Sleep systems also began to show hemispheric specialization, with different aspects of sleep and dreaming becoming lateralized to different brain hemispheres. Your ancestors developed more sophisticated sleep patterns that could serve different functions for each hemisphere, allowing for more efficient neural recovery and memory consolidation. The sleep rhythms that will soon encompass your consciousness tonight represent the culmination of these ancient hemispheric sleep systems. Social behavior reached new levels of complexity with hemispheric specialization, as your ancestors developed enhanced capabilities for processing social information, recognizing individual group members, and engaging in complex social interactions. The right hemisphere's specialization in holistic processing became particularly important for social cognition, enabling sophisticated recognition of social contexts and emotional states. The social comfort you might feel in your safe sleeping environment tonight activates these ancient hemispheric social processing systems. The hemispheric specialization that evolved in your ancestors 150 million years ago established the foundation for all advanced mammalian cognition, creating the neural architecture that would eventually support human language, consciousness, creativity, and abstract thought. As your brain coordinates its hemispheric functions tonight, integrating analytical and holistic processing, managing attention and awareness, and preparing for the complex neural orchestration of sleep, you're experiencing the sophisticated cognitive coordination that began with hemispheric specialization in your ancient mammalian ancestors. In the magnificent tapestry of evolutionary time, approximately 100 million years ago, your ancestors underwent one of the most dramatic expansions in brain size and complexity in the history of neural evolution. These were the ancestors of modern placental mammals, creatures whose brains began to expand exponentially, developing larger and more sophisticated cortical structures that would eventually enable the complex cognitive abilities characterizing advanced mammalian intelligence. Picture your ancestors experiencing a neural renaissance, their brains growing larger and more intricately organized with each passing generation, establishing the foundation for all future advances in mammalian consciousness and intelligence. This cortical expansion represented far more than simply adding more neurons to existing brain structures. Your ancestors were developing qualitatively new forms of neural organization, creating multiple specialized cortical areas that could handle different aspects of sensory processing, motor control, and cognitive function with unprecedented sophistication. The neocortex began to differentiate into dozens of specialized regions, each optimized for particular types of information processing while remaining interconnected through increasingly complex networks of neural pathways. Visual processing underwent remarkable elaboration during this period of cortical expansion. Your ancestors developed multiple visual cortical areas, each specialized for different aspects of visual analysis. Some areas became expert at detecting motion. Others specialized in analyzing object shapes and textures. And still others focused on processing color information and spatial relationships. This distributed visual processing meant that your ancestors could analyze visual scenes with extraordinary detail and precision, creating rich, multifaceted visual experiences that integrated multiple dimensions of visual information. The visual richness that allows you to appreciate the subtle visual qualities of your environment tonight relies on these expanded visual cortical systems. Motor control reached unprecedented levels of sophistication as motor cortical areas proliferated and developed fine-tuned control over different muscle groups throughout the body. Your ancestors could now engage in incredibly precise, skilled movements that required conscious planning and real-time adjustment. Complex behaviors like climbing, manipulating objects, and coordinated group activities became possible as motor cortical systems learned to orchestrate intricate patterns of muscle activation with millimeter precision and millisecond timing. The expansion of association cortex represented perhaps the most significant development, as your ancestors evolved brain regions dedicated to integrating information from multiple sensory modalities and cognitive systems. These association areas could combine visual, auditory, tactile, and other sensory information into unified perceptions of environmental situations. Your ancestors were developing the neural foundation for what we now recognize as higher-order thinking, the ability to analyze complex situations that required integrating multiple types of information and generating sophisticated behavioral responses. Memory systems underwent dramatic elaboration during this period of cortical expansion, developing specialized neural networks that could store and retrieve increasingly detailed and complex information. Your ancestors evolved dedicated systems for episodic memory, allowing them to form detailed recollections of specific experiences, complete with contextual information about when, where, and under what circumstances events occurred. Semantic memory systems also became more sophisticated, enabling the accumulation of general knowledge about the world that could be applied to novel situations. Language-related capabilities began to emerge as cortical expansion created neural regions specialized for processing complex acoustic patterns and associating sounds with meanings. While still far from human language, your ancestors developed increasingly sophisticated vocal communication systems that could convey detailed information about environmental conditions, social relationships, and emotional states. These proto-language systems established the neural foundation for all future developments in symbolic communication. Social intelligence reached remarkable new levels as expanded cortical systems enabled your ancestors to develop increasingly sophisticated models of other individuals' knowledge, intentions, and likely behaviors. The theory of mind capabilities that allow humans to understand that others have their own thoughts, beliefs, and motivations began to evolve as cortical networks became capable of maintaining complex models of social relationships and group dynamics. Your ancestors could now engage in sophisticated social strategies that required understanding not just what others were doing, but why they were doing it and how they might respond to different social approaches. Problem-solving abilities expanded dramatically as larger cortical systems enabled more complex forms of reasoning and planning. Your ancestors could now approach environmental challenges through multi-step problem-solving strategies, considering multiple possible solutions and selecting approaches based on anticipated outcomes. This enhanced cognitive flexibility provided enormous advantages in variable environments where survival success depended on the ability to develop innovative solutions to novel challenges. Play behavior became more elaborate and cognitively complex as expanded cortical systems created enhanced capabilities for learning through exploratory and imaginative activities. Young mammals could now engage in sophisticated play behaviors that combined physical skill development with cognitive challenges, social interaction, and creative exploration. These complex play behaviors served crucial functions in brain development, allowing growing neural systems to practice and refine the cognitive abilities they would need for adult success. The expanded cortical systems also developed increasingly sophisticated mechanisms for attention, control, and consciousness regulation. Your ancestors could now maintain focused attention on complex tasks while simultaneously monitoring their environment for important changes. This enhanced attention control created possibilities for sustained, goal-directed activities that required maintaining cognitive focus over extended periods despite potential distractions. Sleep and dreaming underwent significant changes with cortical expansion, as larger brain systems required more sophisticated mechanisms for neural maintenance and memory consolidation. Your ancestors developed increasingly complex sleep patterns that could serve the distinct needs of different brain systems, with REM sleep becoming more elaborate and serving essential functions in emotional processing and memory integration. Stress management and emotional regulation also became more sophisticated as expanded cortical systems developed enhanced capabilities for modulating emotional responses and coping with challenging situations. Your ancestors could now engage in cognitive strategies for managing stress and emotional challenges, using higher-order cognitive processes to influence their emotional states and behavioral responses. The cortical expansion that occurred in your ancestors 100 million years ago created the neural foundation for virtually all advanced mammalian cognitive abilities. As your own expanded cortical systems coordinate their complex activities tonight, processing multiple streams of sensory information, integrating memories and emotions, planning future activities, and gradually transitioning toward the specialized neural states that characterize sleep, you're experiencing the culmination of this ancient cortical expansion that transformed the possibilities of conscious experience and intelligent behavior. Across the vast epochs of evolutionary time, approximately 65 million years ago, your ancestors survived one of the most catastrophic events in Earth's history and emerged into a new world with unprecedented opportunities for neural and social evolution. The extinction of dinosaurs opened ecological niches that allowed your mammalian ancestors to radiate into diverse environments, developing increasingly sophisticated brains that could support complex social behaviors, communication systems, and cooperative strategies. Picture your ancestors as early primates and other advanced mammals, their brains evolving new neural circuits dedicated to understanding social relationships, coordinating group activities, and navigating the intricate challenges of life in sophisticated animal societies. The social brain revolution represented a fundamental shift in neural evolution as your ancestors developed specialized brain regions dedicated to processing social information with the same precision and sophistication that earlier neural systems had devoted to sensory and motor processing. The temporal parietal junction, superior temporal sulcus, and other brain regions became specialized social processing centers that could analyze facial expressions, interpret social gestures, predict others' behaviors, and coordinate complex group activities. Your ancestors were developing the first versions of what neuroscientists now call social cognition, the sophisticated mental abilities that make complex social life possible. Face recognition reached remarkable levels of sophistication as your ancestors evolved dedicated neural systems for identifying individual members of their social groups based on subtle facial features, expressions, and behavioral patterns. The fusiform face area and related brain regions became expert at extracting socially relevant information from facial cues, enabling your ancestors to recognize friends, identify potential threats, interpret emotional states, and navigate complex social hierarchies. The automatic face recognition that allows you to immediately identify familiar people relies on these ancient social brain systems that first evolved for managing complex social relationships. Communication underwent revolutionary development during this period, as your ancestors evolved increasingly sophisticated systems for sharing information through vocalizations, gestures, facial expressions, and body postures. These communication systems enabled coordination of group activities like cooperative hunting, territory defense, childcare, and resource sharing. The neural circuits that process and generate communicative signals became more elaborate, establishing the foundation for the complex language capabilities that would eventually characterize human communication. The ease with which you understand vocal communication tonight draws upon these ancient social communication systems. Cooperation and reciprocity became central features of social behavior as your ancestors evolved neural systems that could track social relationships over time, remember who had helped or harmed them in the past, and adjust their behavior toward others based on their history of interactions. These reciprocal altruism systems enabled complex social strategies that could provide mutual benefits to all participants, creating the first animal societies based on long-term cooperative relationships rather than simply immediate self-interest. the social trust and cooperation that characterize healthy human relationships rely on these ancient neural systems for tracking and managing reciprocal social exchanges. Group coordination reached unprecedented levels of sophistication. As neural systems evolved, they could enable your ancestors to work together toward common goals that required sustained, coordinated effort from multiple individuals. Cooperative hunting became more elaborate, with different individuals playing specialized roles in complex group strategies for capturing large or dangerous prey. Territory defense became a community effort, with group members coordinating their responses to threats and sharing the responsibilities of maintaining territorial boundaries. The teamwork and group coordination abilities that characterize successful human collaboration are built upon these ancient neural systems for social cooperation. Parental care and family relationships became increasingly complex as social brain systems enabled more sophisticated recognition of kinship relationships and more elaborate caregiving behaviors. Your ancestors developed enhanced capabilities for recognizing their own offspring, providing extended periods of nurturing and protection, and teaching young individuals the complex skills they would need for adult success. These enhanced family relationship systems created stronger bonds between parents and offspring, contributing to the longer developmental periods that allowed for more extensive learning and brain development. Social learning and cultural transmission began to emerge as your ancestors developed the ability to learn complex behaviors through observation and imitation of other group members. Skilled behaviors could now be passed from experienced individuals to novices through social learning, creating the first primitive forms of cultural transmission. Young members of social groups could learn feeding techniques, territorial strategies, and social skills by watching and imitating successful adults, dramatically accelerating the acquisition of complex survival skills. Empathy and emotional contagion reached new levels of sophistication as social brain systems evolved the ability to recognize and internally simulate the emotional states of other group members. Your ancestors could now experience something approaching what others were feeling, creating the foundation for empathetic responses and prosocial behaviors. Mirror neuron systems began to evolve, enabling individuals to understand others' actions and emotions through internal simulation of what they observed. The empathy and emotional understanding that enrich human relationships rely on these ancient neural systems for social emotional processing. Social hierarchies became more complex and flexible as neural systems evolved that could track changing dominance relationships and adjust behavior appropriately to different social contexts. Your ancestors could now navigate situations where social rank might vary depending on the specific circumstances, showing appropriate deference to higher-ranking individuals while maintaining their own social position when circumstances permitted. These flexible social systems created more stable and cooperative group structures that could adapt to changing conditions while maintaining group cohesion. Conflict resolution and reconciliation became important components of social behavior. As your ancestors developed neural systems that could manage the inevitable conflicts that arise in complex social groups while maintaining the cooperative relationships essential for group success. Post-conflict reconciliation behaviors helped repair social bonds after disputes, ensuring that temporary conflicts didn't permanently damage important social relationships. The social skills that allow humans to resolve conflicts and maintain relationships through difficult periods are built upon these ancient neural systems for social repair and conflict management. Play behavior became increasingly social and cognitively complex as group-living ancestors evolved elaborate systems for learning social skills and relationship management through playful interactions. Social play provided safe contexts for practicing social behaviors, establishing relationships, and learning the complex rules that governed group life. These playful social interactions contributed significantly to social and cognitive development, helping young individuals develop the social intelligence they would need for successful adult group participation. The social brain systems that evolved in your ancestors 65 million years ago established the neural foundation for all advanced social behaviors, from the complex family relationships and friendships that enrich human life to the large-scale cooperative societies that characterize human civilization. As your brain processes social information tonight, maintaining awareness of your social connections, even as you prepare for sleep, and coordinates the social comfort and security that enable peaceful rest, you're experiencing the sophisticated social intelligence that began evolving in your ancient social ancestors. In the Grand Chronicle of Neural Evolution, approximately 40 million years ago, your ancestors achieved one of the most remarkable developments in the history of brain evolution: the emergence of the prefrontal cortex as a sophisticated center for planning, decision-making, and executive control. These early primates, your direct ancestors in the lineage leading to human consciousness, developed brain regions that could override immediate impulses, plan complex sequences of actions, and make decisions based on anticipated future consequences, rather than just immediate circumstances. Picture your ancestors developing the first versions of what we recognize as willpower, self-control, and strategic thinking, the cognitive abilities that allow conscious beings to shape their own behavior according to long-term goals and values. The prefrontal cortex represented nature's most sophisticated experiment in neural executive control, creating brain systems that could serve as the command center for all other neural activities. Unlike earlier brain developments that added new capabilities while leaving existing systems largely unchanged, the prefrontal cortex evolved to coordinate and control the activities of other brain regions, creating unified, goal-directed behavior that could persist across time despite changing circumstances and competing impulses. Your ancestors were developing the first versions of what psychologists now call executive function, the mental abilities that allow conscious control over thoughts, emotions, and behaviors. Planning and foresight reached unprecedented levels of sophistication as prefrontal systems evolved the capability to model possible future scenarios and select behaviors based on anticipated outcomes. Your ancestors could now engage in complex planning processes that considered multiple possible future states, evaluated the likely consequences of different action choices, and selected behavioral strategies that would maximize long-term benefits, even if they required short-term sacrifices. The planning abilities that allow you to organize your daily activities and work toward long-term goals rely on these ancient prefrontal planning systems. Working memory underwent revolutionary development as the prefrontal cortex evolved, specialized systems for temporarily maintaining and manipulating information in conscious awareness. Your ancestors could now hold multiple pieces of information in mind simultaneously while performing mental operations on this information, enabling complex reasoning processes that required considering multiple variables at once. These working memory systems created the foundation for abstract thinking, mathematical reasoning, and complex problem solving. The mental abilities that allow you to follow this complex narrative tonight while simultaneously processing multiple streams of information rely on these ancient working memory systems. Impulse control and emotional regulation reached new levels of sophistication as prefrontal systems evolved the ability to modulate the activity of emotional brain centers, allowing reasoned consideration to override immediate emotional impulses when circumstances required it. Your ancestors could now delay gratification, resist immediate temptations in favor of long-term benefits, and maintain emotional equilibrium in challenging situations. These emotional regulation capabilities enabled much more flexible and adaptive responses to environmental challenges, particularly in complex social situations where immediate emotional reactions might be counterproductive. Decision-making processes became increasingly sophisticated as prefrontal systems developed the ability to evaluate options systematically, weighing costs and benefits while considering multiple factors simultaneously. Your ancestors could now make complex decisions that integrated logical analysis with emotional considerations, social factors, and long-term strategic thinking. These advanced decision-making capabilities provided enormous advantages in environments where survival success depended on making optimal choices among multiple competing alternatives. Attention control reached remarkable levels of sophistication as prefrontal systems evolved the ability to direct and sustain conscious attention according to internal goals rather than simply responding to external stimuli. Your ancestors could now maintain focused attention on important tasks despite distractions, shift attention flexibly between different aspects of complex situations, and divide attention efficiently among multiple concurrent activities. These attention control abilities enabled much more efficient learning and problem solving by ensuring that neural resources were allocated optimally according to current priorities. Self-awareness and metacognition began to emerge as prefrontal systems developed the ability to monitor and evaluate their own mental processes. Your ancestors could now think about thinking, becoming aware of their own cognitive strengths and limitations, and adjusting their thinking strategies accordingly. This metacognitive awareness enabled more effective learning and problem solving by allowing individuals to recognize when their current approaches weren't working and needed to be modified. Social cognition was revolutionized by prefrontal development, as these brain systems enabled increasingly sophisticated understanding of others' mental states, intentions, and motivations. Your ancestors could now engage in complex social planning that considered not just what others were likely to do, but what they were thinking and feeling and how they might respond to different social approaches. These enhanced social cognitive abilities enabled much more sophisticated social strategies and more effective cooperation and communication. Abstract thinking capabilities emerged as prefrontal systems developed the ability to manipulate concepts and relationships that weren't directly tied to immediate sensory experience. Your ancestors could now think about general principles, consider hypothetical scenarios, and reason about abstract relationships between concepts. These abstract thinking abilities created possibilities for much more flexible and creative approaches to environmental challenges and established the foundation for symbolic thinking and eventual language development. Moral reasoning and value-based decision-making began to evolve as prefrontal systems developed the ability to evaluate behaviors according to internal standards of right and wrong, rather than simply immediate costs and benefits. Your ancestors could now make behavioral choices based on principles and values that guided their actions, even when those choices weren't immediately advantageous. These moral reasoning capabilities enabled more sophisticated and stable social relationships based on shared values and ethical principles. Creativity and innovation reached new levels as prefrontal systems enabled flexible recombination of existing knowledge and skills to generate novel solutions to environmental challenges. Your ancestors could now approach problems creatively, developing innovative strategies that hadn't been used before by combining familiar elements in new ways. This creative problem-solving ability provided significant advantages in changing environments, where traditional approaches might no longer be effective. The prefrontal cortex also enabled increasingly sophisticated integration of cognitive and emotional processing, allowing your ancestors to make decisions that optimally balanced rational analysis with emotional wisdom. Rather than simply suppressing emotions, advanced prefrontal systems could incorporate emotional information into decision-making processes while maintaining executive control over behavioral responses. The executive control systems that evolved in your ancestors' prefrontal cortex 40 million years ago established the neural foundation for all higher-order human cognitive abilities, from the complex planning and decision-making that guide daily life to the self-awareness and emotional regulation that enable personal growth and meaningful relationships. As your prefrontal cortex coordinates its executive functions tonight, maintaining goal-directed behavior while managing attention, integrating multiple streams of information, and gradually allowing conscious control to relax as you prepare for sleep. You're experiencing the sophisticated executive abilities that represent one of evolution's greatest achievements in neural complexity and conscious control. Time flows like a gentle current through the vast ocean of evolutionary development, bringing us to approximately 25 million years ago, when your ancestors achieved one of the most revolutionary breakthroughs in the history of neural evolution, the development of sophisticated neural circuits dedicated specifically to language and symbolic communication. These early ancestral primates were evolving brain regions that could associate arbitrary sounds and gestures with specific meanings, combine these symbolic elements according to systematic rules, and use these communication systems to share complex information about past experiences, current situations, and future plans. Picture your ancestors developing the first glimmers of what would eventually become human language. The remarkable ability to use symbols to create shared meanings and transmit complex ideas across individuals and generations. Language-specialized brain regions began to emerge as evolution experimented with neural systems that could handle symbolic processing with unprecedented sophistication. The areas that would eventually become Broca's and Wernicke's regions started developing enhanced capabilities for processing sequential acoustic patterns, extracting meaningful elements from complex sound streams, and coordinating the motor activities required for producing complex vocalizations. Your ancestors were pioneering the neural architecture that would eventually enable humans to communicate through infinitely flexible combinations of symbolic elements. Symbolic thinking underwent revolutionary development as these specialized brain regions enabled your ancestors to use arbitrary signs, sounds, and gestures to represent objects, actions, and concepts that weren't immediately present in their environment. This symbolic capability meant that communication was no longer limited to immediate circumstances, but could refer to past events, future possibilities, abstract concepts, and hypothetical scenarios. Your ancestors could now share information about distant territories, remember and communicate complex experiences, and coordinate activities that required shared understanding of plans and strategies. The neural circuits supporting language showed remarkable specialization for processing hierarchical structures, enabling your ancestors to understand and produce communications that embedded smaller, meaningful units within larger structures, according to systematic organizational principles. This hierarchical processing capability established the foundation for grammatical organization, allowing increasingly complex messages to be constructed from simpler elements combined according to learned rules. The language comprehension that allows you to understand the complex grammatical structures in these sentences tonight relies on these ancient hierarchical processing systems. Vocal control reached unprecedented levels of sophistication as language-related. Brain regions developed enhanced connections with motor systems controlling the muscles of the larynx, tongue, lips, and respiratory system. Your ancestors could now produce increasingly precise and varied vocalizations, creating the acoustic flexibility necessary for complex vocal communication systems. These enhanced vocal control systems enabled the production of the diverse speech sounds that characterize human language, establishing the motor foundation for all future developments in spoken communication. Memory systems underwent significant modifications to support language capabilities, developing specialized mechanisms for storing and retrieving symbolic information, learning new word meaning associations, and maintaining the complex networks of semantic relationships that characterize sophisticated language systems. Your ancestors evolved enhanced capabilities for learning new symbolic associations throughout their lifetimes, creating the flexibility necessary for developing rich and evolving communication systems that could adapt to changing social and environmental circumstances. Social coordination was transformed by the emergence of language capabilities, as your ancestors could now share detailed information about complex group activities, coordinate elaborate cooperative strategies, and maintain social relationships through symbolic communication that transcended immediate physical presence. Language enabled new forms of social learning where knowledge and skills could be transmitted through verbal instruction rather than only through observation and imitation, dramatically accelerating the accumulation and transmission of cultural information. The development of language-related neural circuits also enhanced abstract thinking capabilities, as symbolic processing systems enabled your ancestors to manipulate concepts and relationships that existed independently of immediate sensory experience. They could now reason about general principles, consider hypothetical scenarios, and communicate about abstract relationships between concepts. This enhancement of abstract thinking through symbolic processing created new possibilities for complex reasoning and creative problem-solving. Temporal communication became possible as language systems enabled your ancestors to communicate about events displaced in time, sharing information about past experiences and coordinating future activities through symbolic reference to non-present temporal contexts. This temporal displacement capability revolutionized social coordination, allowing groups to maintain continuity of purpose and shared understanding across extended periods and changing circumstances. Cultural transmission reached new levels of sophistication as language systems enabled detailed verbal instruction and sharing of complex cultural knowledge that could be preserved and transmitted across generations. Skills, knowledge, stories, and social practices could now be communicated through symbolic means, creating the foundation for cumulative cultural evolution where each generation could build upon the accumulated knowledge of their predecessors. Theory of mind capabilities were enhanced by language development, as symbolic communication enabled your ancestors to share information about mental states, intentions, beliefs, and desires. They could now communicate not just about external events, but about their internal experiences and the assumed internal experiences of others, enabling much more sophisticated social cognition and interpersonal understanding. The neural integration required for language processing created enhanced connectivity between different brain regions, strengthening the communication pathways that allowed diverse neural systems to coordinate their activities in support of complex symbolic processing. This enhanced neural integration contributed to improvements in many cognitive abilities beyond language, as better connected brain systems could support more sophisticated forms of learning, memory, reasoning, and creative thinking. Creativity was enhanced by language capabilities, as symbolic processing systems enabled your ancestors to combine concepts and ideas in novel ways, creating new meanings through metaphorical thinking and analogical reasoning. The flexibility of symbolic systems allowed for creative expression and innovative thinking that could generate new solutions to environmental and social challenges. Play behavior became more elaborate and linguistically rich as your ancestors developed the ability to use symbolic communication in playful contexts, creating the foundation for storytelling, imagination, and creative expression that would become central to human cultural development. Language-enhanced play provided important contexts for practicing communication skills, while exploring creative and imaginative possibilities. The language-specialized neural circuits that evolved in your ancestors 25 million years ago established the foundation for all human communicative and symbolic capabilities. From the everyday conversations that maintain social relationships to the complex linguistic and symbolic systems that enable literature, science, philosophy, and art. As your brain processes the linguistic information in this narrative tonight, accessing word meanings, parsing grammatical structures, and integrating symbolic content with existing knowledge and memories, you're experiencing the sophisticated language capabilities that represent one of evolution's most remarkable achievements in neural specialization and symbolic processing. In the magnificent chronicle of neural evolution, Approximately 10 million years ago, your ancestors stood on the threshold of the most extraordinary development in the history of consciousness, the emergence of self-awareness and reflective consciousness. These advanced primates, direct ancestors in the lineage leading to human beings, began to develop neural systems that could not only process information about their environment and coordinate complex behaviors, but could also become aware of their own mental processes, recognize themselves as distinct entities separate from their environment, and engage in reflective thinking about their own thoughts and experiences. Picture your ancestors experiencing the first dawning moments of self-consciousness, the remarkable awareness that would eventually enable humans to contemplate their own existence and place in the universe. Self-recognition emerged as your ancestors developed neural systems that could integrate information from multiple sensory modalities to create unified representations of their own bodies and identities. The mirror self-recognition that characterizes advanced consciousness began to evolve as brain systems learned to coordinate visual information about physical appearance with proprioceptive and kinesthetic information about body position and movement. Your ancestors could now recognize their own reflection, understanding that the image they saw represented their own physical form rather than another individual. This self-recognition capability established the foundation for all more complex forms of self-awareness and personal identity. Metacognition reached new levels of sophistication as your ancestors developed the ability to think about thinking, becoming aware of their own mental processes, and able to monitor and evaluate their own cognitive performance. They could now recognize when they knew something versus when they were uncertain, adjust their thinking strategies based on their assessment of their own cognitive effectiveness, and engage in deliberate learning processes guided by awareness of their own knowledge and limitations. The metacognitive awareness that allows you to monitor your own understanding as you listen to this narrative relies on neural systems that first evolved in your self-aware ancestors. Internal mental modeling became increasingly sophisticated as consciousness-supporting brain systems developed the ability to create detailed internal representations not just of external environments, but of internal mental states and processes. Your ancestors could now maintain complex mental models of their own psychological states, tracking their moods, motivations, beliefs, and intentions with the same precision they applied to monitoring external environmental conditions. This internal modeling capability created the foundation for sophisticated self-understanding and psychological insight. Temporal self-awareness emerged as your ancestors developed the ability to maintain continuous awareness of personal identity across time, recognizing themselves as the same individual who had existed in the past and would continue to exist in the future. This temporal continuity of self-awareness enabled new forms of personal planning and goal setting that could span extended periods, as well as the development of personal narratives that created coherent stories of individual life experiences. The sense of personal continuity that connects your past experiences with your current awareness tonight relies on these ancient systems for temporal self-awareness. Intentionality and agency reached new levels of conscious control as your ancestors developed enhanced awareness of their own intentions, goals, and decision-making processes. They could now consciously direct their mental attention, deliberately choose among different behavioral options, and monitor the relationship between their intentions and their actual behaviors. This conscious control over mental and behavioral processes enabled much more. Sophisticated forms of self-regulation and purposeful action guided by consciously held goals and values. Social self-awareness evolved as consciousness-supporting brain systems, enabled your ancestors to understand how they appeared to others and to model others' perceptions and evaluations of their behavior. They could now engage in sophisticated social cognition that included awareness of their own social identity, reputation, and relationships. This social self-awareness enabled much more nuanced social strategies and interpersonal relationships. based on conscious understanding of social dynamics and personal social standing. Emotional self-awareness became increasingly sophisticated as your ancestors developed the ability to recognize, understand, and consciously regulate their own emotional states. They could now identify their emotions, understand the circumstances that triggered different emotional responses, and engage in deliberate emotion regulation strategies. This emotional self-awareness created possibilities for much more. Sophisticated emotional intelligence and interpersonal relationships based on conscious emotional understanding and management. Memory and self-narrative began to integrate as conscious awareness enabled your ancestors to create coherent stories about their own life experiences, linking past events into meaningful personal narratives that contributed to stable self-identity and future planning. These personal narratives helped organize memories around themes of personal significance and meaning, creating rich autobiographical memory systems that supported sophisticated self-understanding and personal growth. Values and moral self-evaluation emerged as consciousness enabled your ancestors to develop internal standards for evaluating their own behavior and making choices based on consciously held principles rather than just immediate circumstances. They could now engage in moral reasoning about their own actions, feel emotions like guilt and pride based on self-evaluation against internal standards, and make behavioral choices guided by consciously adopted values and ethical principles. Creative self-expression reached new possibilities as consciousness enabled your ancestors to use their enhanced self-awareness in creative and artistic endeavors, expressing their internal experiences and unique perspectives through various forms of symbolic and aesthetic communication. The foundation for human artistic and creative expression was established as conscious awareness, enabled deliberate creative choices guided by personal aesthetic preferences and expressive intentions. Philosophical awareness began to emerge as consciousness-supporting systems enabled your ancestors to contemplate fundamental questions about existence, meaning, and their place in the larger world. They could now think about abstract concepts like life, death, purpose, and meaning, engaging in the kind of reflective thinking that would eventually characterize human philosophical and spiritual traditions. The capacity for philosophical reflection represents one of consciousness's most remarkable achievements. Problem solving was enhanced by conscious awareness as your ancestors could now deliberately reflect on problem-solving strategies, consciously consider alternative approaches, and learn from their problem-solving experiences through reflective analysis. This conscious approach to problem-solving enabled much more sophisticated and flexible approaches to environmental and social challenges, as well as accumulation of problem-solving expertise through conscious learning and strategy refinement. The emergence of consciousness in your ancestors 10 million years ago represented the culmination of hundreds of millions of years of neural evolution, creating the remarkable capacity for self-aware, reflective experience that characterizes advanced conscious beings. As your own consciousness operates tonight, maintaining self-awareness even as it prepares for the altered states of sleep, integrating multiple streams of conscious experience while monitoring your own mental processes and internal states, you're experiencing the extraordinary conscious capabilities that represent evolution's greatest achievement in neural complexity and subjective experience. Across the vast sweep of evolutionary time, we arrive finally at approximately 300,000 years ago, when your direct human ancestors achieved the ultimate integration of all previous neural developments into the sophisticated, unified consciousness that allows you to understand these words tonight. Modern human beings emerged with brains that could seamlessly coordinate all the neural systems that had evolved over the previous 500 million years, from the basic neural circuits of your most ancient ancestors to the sophisticated consciousness of your immediate human predecessors. Picture your recent ancestors developing the first fully integrated human minds, capable of language, abstract thought, creative expression, complex emotion, sophisticated planning, and the rich inner life that characterizes modern human consciousness. The integration of all neural systems reached unprecedented levels of sophistication as the modern human brain evolved enhanced connectivity between all its diverse regions and subsystems. The reptilian brain modules controlling basic survival functions, the limbic emotional systems, the cortical cognitive centers, the prefrontal executive controls, and the consciousness supporting networks all learn to work together as a unified whole. Your ancestors could now simultaneously coordinate emotional responses, rational analysis, creative thinking, social cognition, and conscious awareness in complex behaviors that utilize the full range of neural capabilities developed over evolutionary history. Language capabilities reached their full flowering as modern human brains evolved the complete neural architecture necessary for infinitely flexible symbolic communication. Your ancestors could now create and understand language of unlimited complexity, using recursive grammatical structures to embed ideas within ideas, temporal markers to communicate about any point in past or future time, and abstract symbolic systems to discuss concepts that existed purely in the realm of thought. The language comprehension that allows you to follow this complex narrative represents the culmination of hundreds of millions of years of neural evolution focused on communication and symbolic processing. Abstract reasoning achieved remarkable sophistication as integrated human neural systems enabled your ancestors to think about mathematical relationships, logical principles, causal mechanisms, and theoretical constructs that existed independently of immediate sensory experience. They could now engage in scientific thinking, mathematical reasoning, philosophical reflection, and theoretical speculation that pushed the boundaries of what neural systems could accomplish. The abstract thinking that allows humans to understand scientific concepts, create mathematical proofs, and develop philosophical theories represents one of evolution's most remarkable cognitive achievements. Creative expression exploded in diversity and sophistication as fully integrated human brains enabled your ancestors to create art, music, literature, and other forms of symbolic expression that combined emotional, cognitive, aesthetic, and technical capabilities in unprecedented ways. Cave paintings, musical instruments, decorative objects, and other archaeological evidence reveals the emergence of rich creative traditions that use the full range of human neural capabilities for expressive and aesthetic purposes. Social complexity reached extraordinary levels as modern human neural integration enabled your ancestors to coordinate large-scale cooperative societies based on shared symbolic systems, complex role specialization, and sophisticated cultural institutions. They could now maintain social relationships with hundreds or thousands of other individuals, participate in elaborate cultural systems that spanned multiple generations, and coordinate large-scale projects that required sustained cooperation among many specialized contributors. Cultural evolution accelerated dramatically as fully integrated human consciousness enabled rapid innovation and transmission of knowledge, skills, technologies, and cultural practices. Each generation could now build substantially upon the achievements of previous generations, creating cumulative cultural development that accelerated far beyond the pace of biological evolution. The cultural achievements of human civilization represent the collective application of integrated human consciousness across thousands of generations. Emotional sophistication reached remarkable levels as modern human neural integration enabled rich, complex emotional experiences that combined immediate emotional responses with cognitive evaluation, social considerations, moral judgments, aesthetic appreciation, and personal reflection. Your ancestors could now experience emotions of extraordinary subtlety and depth, from the complex emotions involved in artistic appreciation to the sophisticated emotional responses involved in moral reasoning and spiritual experience. Self-awareness achieved complete integration with all other neural systems, enabling your ancestors to maintain conscious awareness of their emotional states, cognitive processes, social relationships, moral choices, creative expressions, and life experiences as unified components of coherent personal identities. This integrated self-awareness created possibilities for personal growth, psychological insight, and conscious self-direction that represented the culmination of the long evolutionary development toward conscious control over mental and behavioral processes. Spiritual and philosophical awareness emerged as integrated human consciousness enabled your ancestors to contemplate ultimate questions about existence, meaning, purpose, and their relationship to the larger cosmos. They could now engage in sophisticated spiritual and philosophical thinking that addressed fundamental questions about the nature of reality, consciousness, morality, and human purpose. The capacity for spiritual reflection represents one of the most remarkable achievements of integrated human consciousness. Problem-solving reached extraordinary sophistication as integrated human neural systems enabled your ancestors to approach challenges using the full range of cognitive, emotional, creative, and social capabilities working in coordination. They could now develop complex solutions that integrated technical innovation, social coordination, resource management, and long-term planning in ways that enabled them to thrive in diverse and changing environments across the globe. The learning capabilities of fully integrated human consciousness enabled your ancestors to acquire complex skills, knowledge systems, and cultural competencies throughout their lifetimes, while contributing to the ongoing cultural evolution of their societies. Individual learning and cultural transmission became seamlessly integrated processes that enabled rapid adaptation to new environments and challenges while preserving valuable cultural knowledge across generations. Planning and foresight achieved remarkable temporal sophistication as integrated human consciousness enabled your ancestors to develop and execute complex plans that could span multiple generations, incorporating considerations of resource availability, environmental changes, technological development, and social evolution. The long-term planning capabilities that enable human societies to undertake projects lasting decades or centuries represent one of the most remarkable achievements of integrated neural evolution. As you lie here tonight, your brain integrating sensory input from your environment, accessing memories of your personal experiences, processing the language of this narrative, coordinating emotional responses to create feelings of relaxation and safety, planning for tomorrow's activities while gradually allowing conscious control to relax as you prepare for sleep. You are experiencing the extraordinary integrated consciousness that represents the culmination of 500 million years of neural evolution. Every neuron firing in your brain tonight carries within it the evolutionary wisdom of countless ancestors. Every thought you think connects you to the vast story of consciousness emerging from simple beginnings to achieve the remarkable complexity and capability that characterizes modern human awareness. You are not just an individual human being resting peacefully tonight. You are the living embodiment of evolution's greatest experiment in neural complexity and conscious experience. Your consciousness represents the universe becoming aware of itself through 500 million years of patient evolutionary development. Each neural system that enables your thoughts and experiences having been refined across countless generations of ancestors who survived, learned, adapted, and passed on to you the incredible gift of integrated human consciousness. And so, dear listener, we arrive at this moment of profound recognition where the vast chronicle of neural evolution converges in your own awareness tonight. We've journeyed together through the deep time of consciousness development, from the first tentative electrical whispers between primitive nerve cells in ancient seas to the sophisticated integrated awareness that allows you to understand these words and reflect on your own place in the grand tapestry of evolutionary time. Along the way, we've discovered that neural evolution is not just a scientific story about brain development, but a deeply personal narrative about how every moment of your conscious experience connects you to the most remarkable journey in the history of life on Earth. The temporal vastness we've explored tonight reveals consciousness not as a sudden emergence, but as a patient unfolding across hundreds of millions of years, each generation of ancestors contributing new capabilities, while preserving the essential neural foundations that still operate within your brain as you rest peacefully tonight. From the distributed nerve nets of your most ancient ancestors to the specialized brain regions that process language, coordinate emotions, and maintain self-awareness, every component of your neural architecture carries the evolutionary wisdom of countless generations who faced environmental challenges, developed solutions, and passed on enhanced capabilities to their descendants. So let me ask you once more, gently as I did at this journey's beginning, where are you listening from tonight? And as you consider your location in space, can you also feel your position in time, connected backward through millions of years to every ancestor whose neural innovations contributed to your capacity for thought and awareness? Whether you're drifting towards sleep in Sao Paulo or Stockholm, in Cairo or Chicago, you are experiencing the same fundamental neural processes that connect all human consciousness to its deep evolutionary roots. If you found any insight or wonder in this quiet expedition through the chronicle of neural evolution, I'd be ever so grateful if you'd like the video, perhaps subscribe to this gentle exploration of deep time, and share this journey through the history of consciousness with someone else who might find comfort in understanding their place in the vast story of awareness itself. Your engagement helps ensure that these explorations of evolution's greatest achievements can reach other curious minds who might benefit from understanding their neural heritage. The story of brain evolution that we've shared tonight reveals a profound truth about the nature of human consciousness, that you are not merely an individual thinking being, but the culmination of evolution's most ambitious project, the development of neural systems sophisticated enough for the universe to become conscious of itself through your awareness. Every thought you have, every emotion you experience, every moment of conscious awareness represents hundreds of millions of years of evolutionary development converging in the remarkable phenomenon of your personal consciousness. Your brain is not just an organ that enables thinking. It is evolution's gift to the cosmos, the means by which matter has learned to contemplate its own existence and find meaning in the vast expanse of space and time. Sleep well, fellow traveler through deep time, wherever and whenever you find yourself tonight. May your rest be peaceful, knowing that it is supported by neural systems refined across the ages. And may your dreams be enriched by the awareness that your consciousness connects you to the most extraordinary story ever told, the emergence of awareness itself from the patient unfolding of evolutionary time. In your sleep tonight, the ancient neural rhythms that first synchronized brain activity in your vertebrate ancestors will carry you gently through cycles of restoration and renewal, while the same neural integration that represents evolution's greatest achievement maintains its quiet watch over your well-being until the dawn returns you to wakeful consciousness tomorrow.